Today we're doing parabolas. Actually, that's what basically this whole thing is about. But specifically, standard form of parabolas. Now, vertex form makes them really easy to graph. So our vertex form, just to rehash what that is y equals a times x minus h squared plus k, where hk is the vertex and a is our stretch factor. Now there's some other information that we can get off of this, such as if a is the stretch factor, hk is the vertex, the axis of symmetry is basically h. So it's x equals h is the axis of symmetry. Alright, so that's vertex form. And we didn't talk about this too much yesterday, so I should probably mention it now. If when we draw the graph, say we get something like this, see it opens down. And these open down when a is negative. And when it opens down, that means the vertex is the maximum, because it doesn't go any higher. And then occasionally, we might get a situation where we graph it and it opens up. Doesn't matter where, if it's opening up, and it opens up when a is positive. And just by looking at it, I can see that this is not a max anymore. It's a min. It's a minimum. Do you see what I mean by max and min? Yes? No? Yeah? Okay, good. So that really has very little to do with standard form, other than it was like left over from yesterday. It was part of your homework that popped up that we had actually not talked about. Okay. Today we're going to do a variety of problems with what's called standard form. So standard form looks like this. Y equals ax squared plus bx plus c. Now that's going to be cropping up an awful lot, and we can do this and graph it from this form without changing it, but vertex form is way better. So when we have standard form, we want to get it into vertex form. But in order to do that, we need to know two things. Basically, we need hk, that's the vertex. So we need the vertex, and we need a, the stretch factor. Now, as it just so happens, derp, I'm going to start with a right at the beginning. So let's do an example. So for example, maybe I have y equals x squared plus 2x plus 1. And I want to get, this is standard form, and I see that a is 1, because it's the number in front of x squared, b is 2, is the number in front of x, and c is 1. Now, I actually don't need c, but c does have one little pieceful information. That's going to be what's called the y-intercept. C is the y-intercept. Because remember, y-intercepts happen when x equals 0. So if I were to replace x with 0, you should see here 0 plus 0 plus 1. So 1. So that's the y-intercept. So that's one little useful thing that we can get from standard form, but to graph this, we really want it in vertex form. So we need the vertex. So to get the vertex, h equals negative b over 2 times a. That's going to give me h. And k equals f of negative b over 2a. So let's just get the h. Negative b is negative 2. Because b is 2, so h is negative 2. And a is 1, is the number in front of x squared, so 1. So h is negative 1. Now this might be confusing. K is f of negative b over 2a, but basically what I'm going to do, that's the y value, and this is the x value of the vertex. So I'm going to take that negative 1, and I'm going to come all the way back into here, and I'm going to put it in. Then that will give me k. So k is going to equal negative 1 squared plus 2 times negative 1 plus 1, because I placed that h into there, and k is going to be 1, negative 1 squared is 1, minus 2 plus 1, so k is 0. So my vertex, my hk, is the point negative 1, 0. And my a was 1 to begin with. So my vertex form, and I am running out of room here, so I'll just write it up here. My vertex form from the standard form would be y equals, a was 1, so 1 times x, now it's negative 1 here, so x plus 1 squared, and then there's no k, because it's 0, so plus 0. And that is my vertex form. And from this vertex form, you can graph it just like you did yesterday. No changes. Now, if you're just asked for the vertex, you could stop at finding the vertex. And our y-intercept was that c. Let's try another. Did you follow this process here? Now, you don't need to understand where this came from. This is just something you memorize. And there is a way at the end of the chapter that we can do this without this little piece of information, but for now, we will need it.
So does that F stand for formula? Like we're going to plug it back? Like
it stands for the function name. It's whatever it happens to be, so yeah. It doesn't mean f times that. It's function notation. Remember when we did function notation, we said something like f of x equals x squared plus blah, 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 blah. Maybe instead of having blahs there, I'll say like 5x. So if I wanted the f of 2, I'd replace 2 into this. So 2 squared plus 5 times 2. So when I say f of negative b over 2a, I mean whatever h is, because that's going to be h, put it into here, so and I get k.
F will equal negative 2
No, let's do a clean example, and then, so let's try this one. Y equals negative 2x squared, and hopefully I'll be able to answer your question there by doing another example. All right, so this is the standard form. And from the standard form, I get a equals negative 2, b equals 8, and c equals 3. And if anything weren't there, it's a 0. Now this one is my y-intercept. So it's just one little piece of information, and get off that should it be asked. So I'd say the y-intercept is the point 0, 3. Off of that. All right, but I want this in vertex form. To get it in vertex form, I'm going to do h equals negative b over 2a, just something I'm going to memorize. And negative b is negative 8, and then 2 times negative 2, h is negative 8 over negative 4, which is 2. So when I say f of negative b over 2a, basically what I'm saying is take this h, because h is negative b over 2a, so it's f of h if you want. Or in this case, I'm going to find the f of 2, right? Because h is 2. Basically what I'm saying is you're going to put this into here. So k is going to equal negative 2 times 2 squared plus 8 times 2 plus 3. And then I follow the order of operations to get k. So square first, plus my 16. That's negative 8. So negative 8 plus 16 is 8. And 8 plus 3 is 11. So I have my hk. So my vertex is, I'll answer your question in a second. My vertex is 2, 11. All right, what's your question?
F is the same as K then?
F means whatever this is. So it's different each time. F is the name of the function. It just means the function this. So I replace x with it. If this is going to confuse you, then it really doesn't matter. What you do to get k is you put this h in for x, and that gives you k. So now we have our vertex. Our vertex form is y equals a, x minus h squared plus k. And now I know those. I know a from the beginning. See? A from the beginning. Negative 2. X minus 2 squared plus 11. And from this, I can just graph it like normal. It opens down, which means is this vertex a maximum or minimum? It's a max, because it opens down. It opens like this. It's always good to know which way it should go, just to make sure that when you graph it, you're graphing it beautifully and all that good stuff. Now, sometimes we're going to have a puzzle. Yes, a puzzle. Here's a puzzle. I'm saying puzzle because it's work. So we're going to find the equation of the parabola given a vertex and a point on the parabola. So if you need help with this, your pre-calc classmates, the seniors, know how to do this. They should be experts. Should be experts because they just did this. But here's my vertex, just as an example. My vertex is 1, 3. I just made that up for an example. And another point on the parabola, let's say, is 3, 9. Okay, so if I go, do I have a graph on this? No, I don't. Okay. Oh well. You could plot these if you want, but it doesn't matter. This is your parabola, and we want the equation. Now, we have our vertex form, right? Y equals a, x minus h squared plus k. I know hk, right? I'm given the vertex. So y equals a, x minus 1 squared plus 3. Do you see where I got that? But what am I missing? A. Once I find A, I'm good. Luckily, I have a piece of information. This is a point on the graph. So this is an XY. So off to the side somewhere, I'll go ahead and replace X and Y with these numbers. So this would be X and this is Y. So I have 9 equals A 3 minus 1 squared plus 3. I just replaced my x and y. So I have 9 equals a, 2 squared plus 3, and 2 squared is 4. So 4a plus 3. I'll subtract my 3, get 6. And a is 6/4, which it reduces to 3/2. So I take that 3/2 and I put it in for a. Now I don't want to reuse this point. I just use that point to calculate a. Now I have my vertex form with a is 3/2. And now I could graph it. And we are happy. Let's do another one of those. Because we were finding the equation of the problem. And in order to do that, I need to find a, the stretch factor, if any. Yes.
We're not eating it. We're not. Take your 5
Okay.
Be sure we have Thank you. Paper water?
Yes!
No.
My favorite Algebra 2 class of all.
Can you see lunch in here?
Aren't you excited?
Caroline. Hit my leg. My chair's been here the whole time. You hit my leg. You hit my leg. I didn't know he was actually cooking along the grill. I thought Miss Lynn was.
Now I want a burger.
Ah. You're gonna get one.
That's sad. Okay. So again, we're going to find the equation. To do that, I'm going to use y equals. I'm going to go right to, I don't want to go try the standard form because then I just have to change it to vertex form anyway. So I'm going to start with vertex form.
I have a really stupid question. What's the difference between the vertex and the point?
Huh?
What's the difference between the vertex and the point? I thought.
Well, the vertex, okay, so let's say this is my graph. There, I drew it. Okay, this is a vertex. It's a point. The vertex is a point on the graph. That's true, but it's a special point. It's the point where it like starts, or it's the bottom, or the top is the max or min. Whereas each one of these, like this, any of these, they're just any point. There's nothing special about them.
The vertex is like the origin. It becomes the origin.
Yeah, it's like your starting point, wherever it happens to be. All right, so we'll go ahead and we'll put our vertex in right away. So it's going to be x plus 3 squared minus 5. Now we need to calculate a. Now this time I wasn't given a point in the normal sense, I was given a y-intercept. So we need to recognize the y-intercept would be 0, 7, because x is 0 at a y-intercept. I'm going to use this point in this that I wrote in order to calculate a. And I'll just do that off to the side somewhere. So 7 equals a, well x is 0, so 0 plus 3 squared minus 5. And 3 squared is 9. So I get 9a minus 5. I'll add the 5, so I get 12. And then I divide by 9. And reduce if possible, which it is possible, so 12 over 9 is 4/3. So I take that 4/3 back up, and I say y equals 4/3 x plus 3 squared minus 5. And I have my formula, my vertex form. We'll do one more getting the vertex form, and one more getting the if from standard form. And then you'll have the rest of class to work on your homework, which for some reason isn't even up there.
It's a sign. Should it be?
No more.
Well, it'd be on Monday anyway, so you'll want to get started on it. All right, so let's say the vertex is -1, 3, and the point is 4, -20. Walk me through it. What should we do?
Write down.
Write down our vertex form. All right, now what do we do?
Plug in vertex.
Plug in the vertex. Now what?
Go off to the side and put in the points for
Yep.
X and Y.
Put in our points. So I have,
1, 2, 3.
I
Put
did.
in the points instead of vertex.
Yeah, and actually that's a common mistake. The vertex needs to be your HK. That's why I was saying do the point off to the side so it doesn't confuse you here. A times 4 plus 1 squared plus 3. 4 plus 1 is 5. So we have 5 squared, so that's 25. Subtract our 3, we get -23. And then we get A equals -23 over 25. We do want that as a fraction.
It's the other way. Oh wait, okay.
Yeah, I initially wrote it backwards because I'm a bonobo. All right, so I come back up here. I know A now, right? So Y equals -23 over 25. X plus 1 squared plus 3. I really don't want to have to graph that, but if I did, I could use my calculator with this fraction to do my stretch and estimate with decimals. All right, we'll do one more example of getting the vertex form from a standard form. Now, also, we could do this with a picture. Like if they gave me a picture, say.
No pictures.
No picture.
No work on.
Courtney's hissing at me.
That was me.
Oh.
I
Caroline's
was just
hissing.
thinking in my mind, she just did it.
Both are cats.
Meow. Or snake. Slither, slither.
Snake sounds about right.
Slither, slither.
So if I had a picture,
Oh, very lovely picture, Miss Kane.
Really missed the dot.
hey,
Let's make it bigger.
there. So this would be my
my
vertex.
dots.
Yeah.
Now
Here,
it's yours.
cannonballs. So this would be my vertex, 2, 1, and either one of these would be a point.
What's your point?
And apparently it's 2, 3, 4, 5, 5, 2. And then I would just do the same process I did, but except applied it with a picture instead. But I'm not going to do that example. We've done a couple of those. All right. Then we're going to get this into vertex form. All right, so A equals 4, B equals 7, and C is not there, so 0. So that means my y-intercept is 0.
So it means it's 0, 0.
Well, I don't know where my vertex is yet. I just know I have a y-intercept there. My vertex could be somewhere else. It could be over there. See, y-intercept's over here. So that's just one piece of information I can get from the standard form, is where the y-intercept is. So the y-intercept,
What I'm saying is the y-intercept point is 0, 0.
yes, the y-intercept point is 0, 0. That is correct,
Wait.
because x would be 0.
What form is that up there?
This is standard form. That's what we started class with.
We've never done that before, have we? Just
Standard form, right here. Standard
I
form.
don't.
Okay, so we're going to change standard. Follow along. We're going to change standard form to vertex form.
Okay. So what do we do again?
h,
Poor losing is me.
which is the vertex, the x-coordinate of the vertex is negative b over 2a. This is what we started class with. I knew I had to go back over that. Maybe we should do one more of these after this. So negative b is going to be negative 7. 2a is 2 times 4. So h is negative 7 over 8. Yuck. But we can still use it. Now to get k, I put this in to the original. So that's going to be 4 times negative 7 eighths squared plus 7 times negative 7 eighths. Yes, it's very yucky. I square that, so I get 4 times 49 over 64. 7 squared. I'm squaring that. 7 times 7 is 49, and 8 times 8 is 64. Don't get your undies in a bunch. All right, so now I do 7 times negative 7, because the denominator here is 1, so that's going to be minus 49 over 8.
Mr. Ken, could you at least
A little. All right, so we'll cancel here. So we get 49 over 4. No, not over 4. Over 16. Minus 49 over 8. In order to combine these, I need a common denominator. I'll rename this to 16. So 49 times 2 is 98. And then 49 minus 98 is negative 49. So I get negative 49 over 16. So this is my h and k. This one is just one that happened to work out really nasty. That actually is the most common case. So I have my h and k, and I have my a from the beginning. So my vertex form is y equals 4 x minus this, so that's going to be plus 7 eighths squared, plus k, so minus 49 sixteenths. And that is the answer.
Should it be negative 7?
Since I sense your confusion and wanting death, we'll try one more, just one more. Just one, because I'm getting sick of talking. This is in standard form. What's A?
1/2.
1/2. What's B?
2.
What's C? Negative 8. I mean, we don't really use this yet, but that is our, if we were asked, this is our y-intercept. So our y-intercept is 0, negative 8. I don't think anywhere in your homework does that ask, that isn't on the board yet, ask that, but it is something we'll need to know later. All right, to get from standard form to vertex form, you're going to just need to learn to recognize when you have what. We're going to use h equals negative b over 2a. So h equals negative 2 over 2 times a half. Don't get your undies in a bunch over that either. 2 times a half is 1. So h is negative 2. Now I take that and put it back into the original to get k. So k is a half times negative 2 squared plus 2 times negative 2 minus 8. Negative 2 squared is 4. And 4 times a half, I'm just following order of operations. And I get negative 10 for k. So I have hk, which means I can write my vertex form. Y equals, now what's a? Well, a is the same as it was in the beginning, a half, times x plus 2 squared. Don't forget your squared. Subtract 10. And that's our vertex form. And we are happy because we finished it. Someone has a black eye in this. Their glasses broke. Or they have a spectacle. Alright. That's it. Goodbye.